Hi, good morning, and welcome to the ZP Developer Zone. So we like to do this webinar. Sometimes it happens twice a week. We did do one on Sunday, and now we're doing one on Thursday. And we tend sometimes to have to do twice a week because of all the questions that come in. That said, let me jump straight into it and just say we've got a couple of questions this week. One on measuring pH and one on electronics from ZP for measuring ROS, reactive oxidation species. Let me go a bit quicker. Say, don't forget we have the ZP Academy. We will be doing a refresh on the ZP Academy generally over the kind of vacation period, so sort of December, January. We do have webinars. It's probably worth saying that we have a sort of standard range of materials for people developing biosensors like electronics, screen printed electrodes, biosensors, and then there's that kind of application knowledge that we also have. And so we do weekly webinars, at least several weekly webinars where we actually kind of disseminate some of this information. So that will be for example, we do have collaborations. I do have some academic meetings today where we will discuss various projects that are going on at the moment. We do have jobs. Primarily this is happening at the moment in Norway, and we do have our developer zone, and we do have our workshops. Workshops are pretty good. For example, we do deal with reactive oxidative species in our workshops as well. Let me go a little bit faster and say the workshops, we have them in November. There's one, we have them in both Norway and Coventry, and we also have them in December, both in Norway and Coventry. I should say that if you see a link, I'll put the links underneath the video at the end as well. We do some really good monthly webinars these days. So today I'm going to mention Julie. When I talk about pH monitoring in soil, I'll mention Julie. So there's a webinar that's, it's more than just a webinar as well. These are kind of live demos. So we do have one on Julie, we do have one on Sense It All, and we do have one on Food Sense. Sense It All would be a technology I described today, and Food Sense is a good application of that Sense It All platform as well. So if you're an electronics engineer or an electrochemist or a chemist and you want to see the sort of productization journey, then these are good webinars to actually attend. In the UK in June 2024, we are going to have a conference on the commercialization of electrochemical assays, and early bird registration is open on that. I realize there is a link down here, so I'll make sure I get that link. And I can see it just about against the grey here, but I'll make sure I get a link underneath the video when I finished. We also do workshops on people's sites. So we do what these call these kind of corporate workshops where we go on site and we'll sort of do workshops and demonstrations for people within a business, and we generally kind of 20 people from the business will turn up for those. Underpinning everything I'm going to talk about today is really the screen printed electrode. So I think ZP, I don't think, it is a statement, that the most reproducible screen printed electrodes in the world are actually coming from ZP. If you come to our workshops, you will see us do live demonstrations using our screen printed electrodes and actually having built products upon those screen printed electrodes. And that's really the key, that we make products upon our own products, let's say, and then we make these screen printed electrodes also available for other people as well. And that sort of necessity for quality for us is something that then we're able to give to the larger community, because they can also benefit from our quality. So I'll put some links to those as well. Let me just jump down a little bit. There's also some equipment. So if people are doing lab work, there's EIS instruments. There's also the connectors that they'll need, or the cables that they'll need, and there's also the connectors that they'll need as well. So question number one, somebody wants to monitor for things like ROS, reactive oxidative species, for some time. They did find this board. I mean, it took me a while to find this board on our website, but this board has been superseded now by another board, so I will discuss that. And then somebody else is trying to make pH measurements in soil, and I will also discuss that as well. So question number one, they were asking about this GFET board. This is something that we did quite a while ago, and we've actually replaced it with this single-purpose biosensor circuit. But I do want to say that I'm going to put a link to this as well. So this, you can almost see the improvement on this. The actual sort of circuit itself is now this shielded device here. The rest of this board is actually just a breakout board, so people can make. They can program it, and they can also attach our biosensors to it as well. So it comes with a cable as well for making biosensors as well. So the quick answer is the GFET has been retired. I'd almost describe this as almost like a Generation 3, Generation 4 product at this point, because this was definitely Generation 1, but we've definitely matured a long way since then. And this is what's nice about this board again is it's something that we actually use in some of our continuous monitoring products. I just want to say good morning to Aftab, who's from a company called Technando. He's just happened to be online. So as I say, the board has been retired, but we've now replaced it with a single-purpose biosensor circuit, and this is a much more matured product. So as I say, there's a link here, so that will bring you. I mean, there's some nice resources as well on that page as well, so you can actually see what we're discussing. I mean, you can see all the various cables that come with it. So the GFET is retired, but it's been replaced by the single-purpose biosensor circuit. Question number 2, somebody wants to measure pH both in soil and, well, they want to measure it in soil discretely, so they want to take a test, and they also want to do continuous as well. So I'm just going to answer that question. So we do have something called the Sensi-All platform. What I would want to say about the Sensi-All platform is there is a webinar on this. So I did say there's some webinars, and I think there's about the 13th of December we have a webinar on Sensi-All. Sensi-All, there's an app on the Play Store. This QR code here will take you to that. And I'll describe Sensi-All, and I'll describe its application in doing pH measurements as well. So it's really described as an OEM platform. What an OEM platform means is that its primary intention is actually so that other companies, entrepreneurs and developers can use it as a basis for their own product. As I say, there is a webinar on the 13th of December, so it's probably worth attending that. And again, I'll put the link underneath the video, and the QR code, if you scan that, will take you to the app on the Play Store. It's a very elegant device. This is kind of, this is much more, I would say, consumer grade technology. It fits in the palm of your hand. It's got these LEDs which indicate status, if the device is on, if it's making Bluetooth connection, if it's running an assay, if it's uploaded data. All the lights change color to kind of guide that user experience. And the nice thing about it is it is actually very attractive looking. And also with soil, you'll see in one of the videos in a minute, this device, you can slightly pull it apart. So if somebody smears soil all over it, they can clean it. Now, the way the Sensi-All platform works, I'll just play some materials here as well. So you kind of have a sensor. In this case, this person requires a pH sensor. You have the Sensi-All platform. You have the app. The app is something you can get ahead of time anyway by just scanning that QR code. And then there's also something called Julie. And I did say that we have some webinars on Julie as well. So come to those webinars on Julie. The nice thing about Julie is if you put a sample on the sensor and measure it, it'll immediately make its way up to Julie as well. So the data ends up in the cloud as well. So sensor works with the hardware, and then the app tells the hardware what to do. The hardware gives the data back to back to the app, and then the app uploads the data to Julie. And then depending on the assay, you can get millimolars, ppm, or pH. In this case, it's going to be pH. These are just some videos to kind of, I want to silence that guy, just to guide you. I was mentioning earlier on that it's got quite a nice features about it. So you can put the sensors in and out very easily. But it's also got this feature that you can pull that apart. So if there was some reason, especially if you're in the field and some soil gets on that, you can just give that a good clean down. The other part of this then is an entire system. I'll just silence her. So the app talks to the hardware, and then you make Bluetooth connection with the meter through the app, and then you can, as you can see, she's doing here. She's searching for the hardware, found it, and then she can connect to it. It's really robust because this has been a long time in development, and maturing. And then they actually run an assay, which they're doing in this case, and then that data actually goes up to the Julie cloud. And in fact, that's what they're discussing there as well. So Julie is the only electrochemical data management system in the world. Then we're easily able to change the Sensi-All's direction, let's say, or its application by just using a series of QR codes. So each QR code will then tell the Sensi-All app, today I'm a pH sensor, tomorrow I'm a nitrate sensor, and the day after that I'm a TAS sensor, total antioxidative status. And actually TAS is interesting actually, because I just realized that the gentleman who was asking about ROS, reactive oxidative species, you might want to think about TAS as well. As you know, at ZP we do have a whole series of electrochemical sensors. We do have pH sensors, and we also have something called TAS, total antioxidative status, which I realize is pertinent to reactive oxidative species, which is one of the questioners' inquiries. So this is where you can get the app for Sensi-All. At the moment, these are the QR codes that we've got in the public domain. So each QR code will then take you to, oops-a-daisy, will take you to a different application. So you can see the term Sensi-All means something. Do you want to measure chili? Do you want to measure ginger? Do you want to measure nitrate? Do you want to measure total antioxidative status? So come to that Food Sense webinar as well. So we do have a calibration-free pH sensor system. So calibration-free obviously means what it means. That a big problem with measuring pH, when you're trying to do, I call it a spot test. The spot test is when you have a sample, you put it on a sensor, you get a result, you're done. The sensor's done. That's not the same as continuous measurement. So if you want to do a spot test, one of the biggest problems I would say in pH monitoring is the need for calibration. So what's nice about this then is we have a system, we bundled the sensors with the hardware. Now, I realized here that there's, I've put that link here, which I really didn't want to put it there, but that said, that's okay. So we have a pH kit, and we describe it as a Generation 2 sensors, and I put a link here to it. It's important, see, because that's not the same as the pH sensors that we generally have on the web store. These are Gen 2 pH sensors, which means that they're calibration free. So if you're looking for a calibration free spots test, then this link is for you. If you much want to go your own route, then if you need a data logger, then I would use the single purpose biosensor circuit. And if you need a sensor, this is much more if somebody has a small budget or for whatever reason wants to develop their own technology, then you need two aspects to it. You need electronics, you need sensors. So I'm also going to give you a couple of links to that as well. So essentially you have to build your own. If you're going with the with this data logger, the single purpose biosensor circuit, then you do need to kind of have a bit of an electronics coding background to play with it. But otherwise, that's one route to go as well. So there's two routes. If you just generally want something that kind of works, then it's the Sensi-All Gen 2 pH sensor package that I was on the previous slide. But if you want to do a much more of a kind of academic research topic, then you can go your own way with these pH sensors and with this single purpose biosensor circuit as well. So with that, I want to say thank you. So for the first questioner, we have retired that GFET board. That's quite a long time ago, but we have replaced it with something that's probably I would describe as Generation 4 and a lot better. And I have put some links to that. Regards to the pH sensor, we have overcome one of the biggest issues with pH sensing is the need for calibration. So there is a kit now, the Sensi-All kit with Generation 2 pH sensor. That's ideal for you, but you can also take that different route using those web store pH sensors and that web store single purpose biosensor circuit and essentially build your own sort of technology that way. And because you're a university, that might be the route that you go as well. So I want to say thank you. Special thank you to Aftab from Technando this morning. It's delighted to have you. And if you've got any questions, please don't hesitate to reach out to us. Okay, thanks very much.